should start recording. So today's class, actually I might continue even after 3:20. So if you have class or if you cannot continue after 3:20, so you can just leave the class, and I will also post the recording on YouTube, and I will send you the link. Okay. So do you have any question about exam? Yeah, the exam will be on Cengage, and it will open at 2 p.m. and close at 3:20 p.m. So you will have total 1 hour and 20 minutes to finish the exam. So there will be total 6 questions. Yeah, the questions will be similar to the review problems, but you might not expect to have the exactly same questions. Maybe there will be 1 or 2 questions from the review, maybe with different number, but the questions will be similar. Any other question? Okay. So the first problem is from section 1.2, the number of contaminating particles on a silicon wafer prior to a certain rinsing process. And here we are given the number of particles and the frequency. So the number of particles are from the possible values are from 0 to 14, and we have the corresponding frequencies. So the first problem is, what proportion of the sampled wafers had at least one particle? So at least one means it can have one and more than one particles. So from 1 to 14. So we have to find the proportion for the number of particles from 1 to 14. So one way is you can add all the frequencies for the particles from 1 to 14 and divide by total number of particles is 100. So divide by 100 and you will get the proportion. But here it will take more time. But what you can do, you can do other way. You can consider the complement. So at least one means it cannot have zero particles. So if you subtract the frequency for the zero particle, then it will be, for zero particle we have the frequency is 1, so it will be 100 minus 1, so 99 divided by 100. So the frequency is, sorry, the proportion will be 0.99. And the second part is at least 5. So at least 5 means 5 to 14. So that's mean we have to subtract this frequency. And the frequency for 0 to 4 is 2 plus 6 plus 12, 18 plus 11. So it is 29. So this part will be then 100 minus 29. So it will be 71 divided by 100. So that's mean 0.7.
How did you get 71?
Sorry?
I was like, how did you get 71?
Oh, okay. So you have to add the frequency for the particles from 5 to 14. So if you add the frequency from 5 to 14, and it will take time. So I consider the complement. So that's mean I subtracted the frequency for 0 to 4. So I have added this frequency, and which is 1 plus 2, 3 plus 3, 6 plus 12, 18 plus 11. So it's 29, right? And total is 100. So 100 minus 29 is 71, right?
Yes.
Yeah, 71 divided by 100. Yeah, good question. Okay, so part B is, what proportion of the sampled wafers had between 5 and 10 particles inclusive? So between 5 and 10 particles, and they are inclusive. So inclusive means we have to also consider the frequency for 5 and 10 as well. So you have to add the frequency from 5 to 10. So this is 15 plus 18, so it's 33, plus 10, 43, plus the frequency is 12, So it's 55 plus 4, 59 plus 5. So it's 64. So part B, this is 64 over 100, so 0.64. And when it is strictly between 5 and 10, so that's mean the number of particles between 5 and 10, and strictly between, that's mean we are not going to consider the frequency for 5 and 10. So that's mean you have to consider the frequency from 6 to 9. And we already know the frequency from 5 to 10, which is 64. So from 6 to 9, it will be, you have to subtract this one and this one. So 20, so it will be 44. Or you can add the frequency from 6 to 9. So for 6, it is 18. For 7, it is 10. So 28. For 8, it is 12. So it will be 30, 40. And for 9, it is 4. So it will be 44. So this is 44 divided by 100. So it will be 0.44. And part C is draw a histogram using relative frequency on the vertical axis, and how would you describe the shape of the histogram? Now we have to construct the draw a histogram using relative frequency on the vertical axis. So you have to construct the histogram using relative frequency. So relative frequency means you have to consider the proportion. So on the vertical axis, you have to consider the proportion, and on the horizontal axis, it will be the number of particles. And you have to construct a histogram. Okay, so I'm not going to do this one, but I can give you the idea. So you will calculate the relative frequency for each particles, and then you will the vertical axis will be the proportion, and this axis will be, for example, 0, 1. This will be particle 0, 1, 2, 3, and up to 14. It will be particle. Okay. Okay, so this problem is from section 1.3. So here we have the home sale amounts for a sample of homes in Alameda. So here we have to in the first one, we have to calculate and interpret the sample mean and sample median. So here we have the selling price here in $1,000. So we have to calculate and interpret the sample mean and sample median. So to calculate the sample mean, you have to add them together. You have to add these 10 numbers. How many numbers you have? 2, 6, 4, 6, 8, 10. So we have 10 houses here. So you have to add them together and divide by 10. That will be the sample mean. So for part A, you have to calculate the sample mean. So it will be the sum divided by 10. So you have to add all the numbers and divide by 10. And median will be, first you have to rearrange them in order, either in ascending order, increasing order, or decreasing order. So if you rearrange them in increasing order, then it will be, the smallest one is 350. So the first one will be 350. Then the second one will be, I think, 408. Yes, the third one will be, we have 540. Yes, it will be 540. Then 555. Then 575. Then 590. And then we have 608. Yeah, then we have 679. Then we have 12815. Then 1285. So how many numbers do we have here? We have total 10 prices. So the median will be, in the median we'll have 2 numbers. So we have 2 mid values here. So the two mid values will be these two. So in this case, the median will be the average of these two numbers. So it will be then average of 575 and 590 divided by 2. Since we have two numbers in the middle, so that's why we are adding these two numbers and we are dividing these two numbers by 2 to get the median. And part B is, suppose the sixth observation had been 985 rather than 1285. So that's mean instead of this number, we have actually here 985. So how would the mean and median change? So now we have to calculate the mean in part B. Now calculate the mean, and mean will be sum divided by 10. What do you think? Do we have the same mean or different mean? Do you have same mean as the part A, or we'll have different mean? Yeah, it will be different, right? Yeah, because it was 1285, now it is 985. So now we have a smaller number, so the mean will be smaller. But the median will not change because the middle values, the two middle values are same. Because we just changed this number, so it didn't affect these two numbers, the position of these two numbers. So that's why the median will be same as the median in part A. So it will be same as A. So the median will not change. So you have to make a comment. How would the mean and median change? We'll have a smaller mean, but the same median. So now we have to calculate the 20% trimmed mean by first trimming the two smallest value and two largest value. So 20% trimmed mean you have to trim 20% of the observations from the left and 20% from the right. So 20% of 10 values is 2. So that's mean we have to remove two numbers from the left and two numbers from the right. So that's mean we have to remove these two numbers and we have to remove these two numbers. Then you have to take the sum of the rest of 8 numbers and find the mean for that one. That will be the 20% trimmed mean. So for 20% trimmed mean, the mean will be sum of the 8 number divided by 8. That will be the 20% trimmed mean. Sorry, not 8 number, actually 6, right? Because we removed 2 from left and 2 from right. So that's mean we are removing total 4 numbers. So we'll have 6 numbers, and you have to take the mean of these 6 numbers. So that will be the 20% trimmed mean. And calculate the 15% trimmed mean. So I'm going to show this one, how to calculate the 15% trimmed mean. So to calculate the 15% trimmed mean, 15% mean, we have total. So 15% we have total. So this is 0.15, and we have total 10 numbers, right? So that's mean 1.5. So you have to remove 1.5 observations from the left and 1.5 observations from the right. So how can we remove 1.5 observations? 1.5 means you have to completely remove this number and 50% of this number, 50% of 408. And similarly, from the right, you have to remove this number completely and 50% of this number. So that's mean you can write actually okay, so 15% trimmed mean, that will be mean is equal So you have to remove the first number completely. The first number is 350 and 50% of the second number. So that's mean 408 divided by 2, right? Because you are removing 15%, 50% of the second number. So that's mean 408 divided by 2 plus the next number is 540. So 540, this is 0, plus similarly from the right side, you will remove this number completely. You will remove this number and 50% of 815. So 50% of 815 means the last number will be 815 divided by 2. 50% of the last number. And the previous number is 679. So we can just write 679. So that's mean we removed the first number and we removed the last number and 50% of 408 and 50% of 815, and we added all the other numbers. So dot means you have to consider the other numbers as well. So we have to divide by 8 or 7. Yes, we'll divide by 7, right? Because how many number we removed actually? How many observations we removed? We removed 1 observations from the left completely, 1 observations from the right completely. So 2 and 50% of 408 and 50% of 815. So that's mean we actually removed 3 numbers, 3 values. So that's, and total was 10. So 10 minus 3 is 7. So that's why we are dividing by 7. Okay, so that's how we will calculate the trimmed mean. Do you have any question? Okay, so here, this is from section 1.4. A study of the relationship between age and various visual functions reported the following observations on the area of scleral lamina. So here we have actually, what is the data here? We are given the data here. So this is our data set. Now we have to calculate sigma of xi. So part A is sigma of xi. Here xi means x1, x2, x3 up to, so this is our x1, this is x2, this is x3, this is x4, this is x5, this is x6, this is x7, x8, x9, and 10, 11, 12, 13, 14, 15, 16, 18. So this is x18, this is x17. So we have total 18 numbers here. So summation of xi means you have to add all these 18 numbers. So here I is actually 1 to 18. So this is actually the sum of the data. And sigma of xi square, I is equals to 1 to 18. So that's mean first you will take the square of each number. So that's mean you will take the square of the first one, which is x1. So you have to consider x1 square. So that's mean 2.75 square plus the second number is 2.62 square plus dot plus up to 3.01 square. So you will take the square of each number and you will add them together. That is your sigma of xi square. Now in part B, use the values calculated in part A. So now you have to use this value to calculate the sample variance. So we know the formula for the sample variance, and the sample variance is 1 over n minus 1 summation of xi minus x bar squared. So this is one formula for to calculate the sample variance, and there is another formula which is Okay, so which is 1 over n minus 1 summation of xi square minus n x bar square. So instead of this one, you can also write this is actually x bar is x bar is equal summation of xi divided by n. So you can, instead of this one, you can also write 1 over n summation of xi square. Okay, so instead of this one, you can write 1 over n summation of xi whole square. So now you have summation of xi square. So, and you will get this one from here. So this is your summation of xi square. So you will get this number from here. And you also have sigma of xi or summation of xi from this here. So you have to plug in this number here. Then you have to simplify this one, and n is 18 here. After simplifying this one, you will get s square, the sample variance. Yeah. And to calculate the sample standard deviation, you will just take the square root of the sample variance. So this is our variance, and standard deviation will be standard deviation s is the square root of s square. So you'll take the square root of s square, the sample variance, and you will get the sample standard deviation. Okay, so now we didn't go over this problem in the class. So suppose that vehicles taking a particular freeway exit can turn right and turn left or go straight. So a car has 3 ways to exit the freeway. One way is the vehicle can turn right or turn left or go straight. We have to consider the observing the direction for each of the 3 successive vehicles. So we have 3 vehicles here. The first one is you have to list all the possible outcomes. So list all outcomes in the event A that all 3 vehicles go in the same direction. So you have to list all the possible outcomes where all 3 vehicles go in the same direction. So same direction means the first one go to right, the second one also right, the third one also go to right. And similarly, if the first one go to left, the second one also go in the left direction, and the third one will also go to left. And if the first one go to straight, then second one also straight, and third one also straight. So these are the possible outcomes for the event A. So A will be this one. Part B, list all outcomes in the event B. So event B is that all vehicles take different directions. So all vehicles takes different directions. So that's mean if the first one take right, second one left, third one straight. So, or if first one right. So in this case, the easy way is you will start with one letter and finish all the possible outcomes with that letter. So I started with R. So if the first one is R, the second one could be L or S. We considered L, so the third one will be S. So with R, we can have one more outcome. So the first one is R, so the second one is S, and third one is L. So can we have any other outcome for with R? If we start with R. No, in this case, we cannot have, because all the vehicles turn in different direction, right? Exit in different directions. Now start with S. Then the second one will be either L or R. If we consider L, so third one will be R. Again S, so RL. Now we have one more, So who is L start with L, so it will be LSR LRS. So these are the possible outcomes where the vehicles exit the freeway in different directions. Is it clear, or do you have any question? Okay, part C is list all outcomes in the event C that exactly two of the three vehicles turn right. So event C is two of the three vehicles turn right. So that's mean we have two right, one left, or two right, one straight. Or we can also have the first one is right, second one L, right. And we can have R, S, R, and we can have L, R, R, S, R, R. Exactly two of the vehicles turn right. So we'll have 2R and the third one will be different. So we can have RRL, RRS, or RLR, RSR, LRR, SRR. So part D is event D, list all outcomes in the event D that exactly two vehicles go in the same direction. So exactly two vehicles go in the same direction. So that's mean we can consider exactly 2R. So we already have exactly 2R. You can also consider exactly 2L. You can also consider exactly 2S. So that's mean we'll have actually RRL, RRS, RLR, RSR. Then we'll have LRR, SRR. So exactly two right. Now you can consider exactly two left. So similarly, you can have LLR, LLS, then LRL, LSL, and then you can have, so we are considering, so you can have RLL, SLL. So now you can consider exactly two straight, two vehicles take a straight. So you can consider SSR, SSL, then SRS, SLS, and you can consider RSS and RSS and LSS. So these are the possible outcomes. So exactly two vehicles take in the same direction. So now in part D, so now we have all the events. So list outcomes in D complement. So now we have to consider, you have to find D complement. So we do not have the sample space yet. So the sample space, in the sample space, actually we can have how many outcomes we can have. We can have actually total 1, 2, 3, 4, 5. We have 3 vehicles and 3 directions. So we can have actually 3Q. So 27, total 27 outcomes. So in the sample space, we'll have total 27 outcomes. So the D complement will be from the total 27 outcomes, you have to remove these outcomes from the sample space. So first you need to write the sample space, and sample space will have, this is sample space, and this sample space will have total 27 outcomes. Actually, this problem is little lengthy. So I'm the, maybe if I ask any question in the exam, maybe I will give you like 2 outcomes not 3 outcomes, because here if we have 3 outcomes, then you will have total 27 outcomes. Sorry, 3 options, then you will have total 27 outcomes. And for 2, you will have actually 2 times 2, you will have total 4 outcomes. So that will be more easier. Okay. And in part D, you have C union D. So that's mean you have to C union D means the outcomes either in C or in D, and C intersection D will be the common outcomes. So all the outcomes in C, also the outcomes in D. So that's mean the C intersection D will be actually C. So you can simply write C intersection D will be actually C, and C union D will be actually D. So you do not need to write all the outcomes again. You can just write C union D is D, because C is also in D. So if you take the union, then it will be just D. Okay, so this problem is from section 2.2. So here we have different funds and their percentages. The percentage of customers in the different funds are as follows. So the customer can invest in the money market, short bond or immediate bond, or long bond, or high risk stock, or moderate risk stock, or balanced investment. So the customers can have different type of investment, and here we have the percentage of the fund of different investment. So now a customer who owns shares in just one fund is randomly selected. So a customer who owns shares in just one fund, and the customer is randomly selected. Now the question is, what is the probability that the selected individual owns shares in the balanced fund? So we have to find the probability the customer invested in the balanced fund. So the share, percentage for the balanced fund is 7%. So the probability will be 7%. So it will be 0.07. The part B is, what is the probability that the individual owns shares in a bond fund? So we have to find the probability. So how many bonds we have here? So we have, this is bond, this is also bond, this is also bond. So you are asking the probability that the individual owns shares in bond fund. So probability that the shares in bond fund will be, so short bond is 15%, and intermediate bond is 10%, and long bond is 5%. So total is 15 plus 10, 25 plus 5, so it is 30%. 15% plus 10% plus 5%, so it will be 30%. So this is 0.30. So the probability that the customer invested in the bond is 0.30. In part C, what is the probability that the selected individuals doesn't own shares in a stock fund? Not a stock fund. So that's been the complement of stock. So one way is you can find the probability for the stock fund and subtract it from 1. And the other way is you can calculate the probability for the non-stock fund. So we have a stock here and here. So we have only 2 stock fund, and this is 18% plus 25%. So this is 43%. So you can, what you can do 1 minus 43%. So one way is you can do 1 minus 43%. So 1 minus 0.43. So it will be 0.57. So the probability is the person is not investing in the, not own shares in a stock fund, and the probability is 0.57. Do you have any question? Okay, so consider randomly selecting a student at a large university and let A be the event that the selected student has visa card. Actually, we went over this problem in the class, so I'm not going to go over this problem today. But if you have any question, then maybe we can come back to this problem later. And we have also 26. We also went over this problem in the class. So this is a certain system can experience three different type of defects. So there are three different type of defects: A1, A2, A3. Okay, so what is the probability that the system doesn't have a type 1 defect? So that's mean complement of A1. So what is the probability that the system has both type 1 and type 2? So that's mean the intersection of A1 and A2. So part A, you have to find the probability of A1 complement, and part B, you have to find the probability of A1 intersection A2. And in part C, you have to find the probability of. So we went over this problem in the class, so I'm not going to discuss this one today because we'll not have enough time. Will not have enough time to discuss this. So A1 intersection A2 intersection A3 complement, and part D is the probability that the system has at most two of these defects. So at most two. So the system can have maximum two defects. And the possibility is that the system can have three defects. So it is actually the complements of probability of all three defects. All three defects mean A1 intersection. That's mean you have to find the probability 1 minus probability of it has defect 1 and defect 2 and defect 3. So you have to find this 1 minus probability of A1 intersection A2 intersection A3. So we solved this problem during the class. Okay, so we also solved this problem in the class, so I'm not going to go over this one. Okay, so and we also went over this problem, gas station problem. This is tree diagram, so we discussed this one in the class. And we also discussed problem 60 in the class. So I'm not going to go over this one. And we also went over this one in the class, the blood type. But if we have enough time, we'll come back and we'll try to go over some problems. Okay, I think we didn't go over this one. Consider randomly selecting a single individual and having that person test drives three different vehicles. Defines events A1, A2, and A3 by A1 is likes vehicle numbers 1. So a person gave test drive with three different vehicles. So the event A1 is the person likes number 1 vehicles, and A2 is the person likes vehicle number 2, and A3 is the person likes vehicle number 3. So, and we are given some probabilities here. Now the part A is, what is the probability that the individual likes both vehicle 1 and vehicle 2? So that's when we have to find the probability A1 intersection A2. So we have to find this probability. So how can we find this probability? So if we know that they are independent, then we can directly find this one, but we do not have this information whether these events are independent or not. Okay, so actually they are not independent. If the person likes vehicle numbers 1, that's mean he doesn't like the other vehicles. Actually the person doesn't like the other vehicles. Okay, so we have to consider probability of A1 intersection A2. But how can we calculate this one? One way is we know the formula for A1 union A2. So the formula for this one is probability of A1 plus probability of A2 minus probability of A1 intersection A2. Yeah, now we are given probability of A1 union A2 is 0.80. So we know this probability. So this is 0.80. And we also know the probability of A1. This is 0.55 plus. Probability of A2 is 0.65. This is 0.65 minus probability of A1 intersection A2. Now we have to solve this equation for this one. So you have to solve this equation for this one. So that's mean probability of A1 intersection A2 will be then 0.55 plus 0.65 minus 0.80. So it will be then 0.40. So the probability of A1 intersection A2 is 0.40. Do you have any question? Okay, the second part is conditional probability. So we have to determine the and interpret probability of A2 given A3. So the probability A2 given A3. So first we have to calculate the probability of A2 given A3. So we know can anyone tell me the formula for the conditional probability? So how can we calculate this probability? Anyone? So what should we write in the denominator? Probability of the
A3. A3.
Yes, probability of A3, right? Because the given event is A3. Thank you. So in the denominator, it will be probability of A3. And in the numerator, it will be the intersection of A2 and A3. Okay. So now the question is, we have to check whether intersection of A2, A3 is given or not. Yes, it is. Here it is given. So the intersection is 0.40. So, and probability of A3 is 0.70. So it will be then 0.40 divided by 0.70. So this is the conditional probability. Now we have to interpret these results. Actually, this means that this information is given. So the given information is the person liked vehicle number 3. So we already know that the person liked vehicle number 3. Now, what is the probability that the person likes vehicle number 2? So this means actually we learned that, or we know that the person likes vehicle number 3. What is the probability that the person's likes vehicle number 2? So this probability actually means we learned that the person likes vehicle number 3, and the probability that the person likes vehicle number 2 will be this one. That's the interpretation of this result. And this is the question actually. This is question, and If you explain the answers, that will be the interpretation of these results. Okay, so what is part C here? Are A2, A3 independent events? What do you think? Are they independent? Okay, so I got 3 answer. 2 of you said no. Oh, I got 4 answer. 3 of you said no. Yeah, 4 of you said no. I got 1 yes and 4 no. Okay, let us check whether they are independent or not. So to check the independency, so in part C, you have to check whether A2 and A3 independent. So we have to check this one. So how can we check this? So one way is if the conditional probability A2 given A3 is equal probability of A2. So that means if the probability of A2 doesn't depend on the probability of A3, then they will be independent. Now check whether this one is equal A2 or not. So here we found the probability is 0.40, the 0.4 divided by 0.7. So 0.4 divided by 0.7 is, let me calculate it. So 0.4 divided 0.7, which is 0.571. So this is equal 0.571. So let me check whether this is equal probability of A2 or not. So probability of A2 is 0.65. So they are not same. So that's mean A2 and A3 are not independent. So they are not equal. So they are not independent. Because probability of A2 is 0.65 and this one is 0.571. So they are not same. So that's mean they are not independent. And another way is we have the probability of the intersection. And another way is you can calculate, we already have this one. So you have to check whether this is equal probability of A2 times probability of A3 or not. If they are same, then they are independent. If they are not same, then they are not independent. So check this one. Okay. So we have one more part here. So the last part is if you learn that the individual didn't like vehicle number 1. So this information is given. If you learned that, we learned that the individual didn't like vehicle number 1. So that's mean A1 complement is given. Didn't like means A1 complement. So A1 complement is given. What now is the probability that he or she liked at least one of the other 2 vehicles? So at least one of the other 2 vehicles means either A2 or A3, right? So at least other 2 means A2 union A3. And the given information is A1 complement. So we have this information. We have to find this probability. So how can we calculate this probability? One way is you can construct the Venn diagram. So that's the easiest way to calculate the probability for this type of problems, or you can use the formula. So here we learned that so part D is we learned that the person didn't like vehicle number 1. And what is the probability that the person likes either A2 or A3? So we are given that A1 complement. Okay. So you can calculate this probability. So this is actually probability of A2 union A3 intersection A1 complement divided by probability of A1 complement. So actually it is better to construct the Venn diagram for this type of problem instead of using the formula, because if you want to use formula, that's a little complicated, but if you use the Venn diagram, that will be easier. So we have three events. So suppose this is A1, this is A2, and this is A3. So we have A1 intersection A2 intersection A3. So no, we do not have Excel. We have to also calculate. So Venn diagram will be also a little tricky. Yeah. So you have to calculate so many probabilities. So let's try to use the formula then. Because if you want to construct the Venn diagram, you have to also calculate some other probabilities, because you have to calculate this part, which is the intersection of all three, which is not given. So you have to also calculate this one. Okay. So how can we calculate this one? So we know that the probability of A intersection, suppose B complement. So this is actually, so A intersection B complement, suppose if we have two events. So suppose if this is A, this is B, then B complement means outside B, and intersection of A, so that's mean this part. So that's mean this is probability of A minus probability of A intersection B. So if you want to use the formula, then this is the formula for A intersection B complement. So now we can consider this one as a single probability. So single event, A2 union A3. So we have A2 union A3 intersection A complement. So let's calculate this one first. So if you want to calculate this one first, then it will be probability of A2 union A3 intersection A complement. So this is equal actually probability of A2 union A3 minus probability of intersection of this one and this one. So that's mean A2 union A3 intersection A1. Okay. So now we already know this probability. So this probability we already know, A2 union A3. So from that one we can directly write this probability. Now we have to calculate A2 union A3 and intersection A1. So to calculate this part, so this part is actually A2 union A3 intersection A1. So this one actually we can write this one as, we can consider probability of A2, we can consider this one as probability of, so we can consider this one together, then it will be probability of A2 plus probability of A3 intersection A1 plus minus probability of intersection of all three. So minus probability of A1 intersection A2 intersection A3. Okay, so we know this probability, we know this probability, and you can also calculate this probability, because to calculate this one, actually we have the union of all three. So we have A1 union A2 union A3 here. So you can use the formula for union of this one to calculate the probability for the intersection of A1, A2, A3. Actually, to complete the part D, you have to calculate actually so many probabilities. So part D, so even if you want to construct the Venn diagram, you have to calculate probability of A1 intersection A2 intersection A3. So now after calculating this probability, you have to just plug in this number, and you already know this one, and you already know this one. So you have to just plug in these numbers and you will get this probability. And if you plug in this one here, then you will get the probability for the numerator. And the conditional probability is, so you will get the probability for the numerator, and this one is just probability of A1 complement. This is just 1 minus probability of A1. And you know the probability of A1, so you can calculate this one. So that will be the denominator. Do you have any question? Yeah, per day is little complicated. It will take little more time because you have to calculate so many probabilities. You have to calculate intersection of all three. You have to calculate, yeah, just you have to calculate probability intersection of all three. That's it. Okay. So from chapter 3, from section 3.1, so for each random variable defined here, describe the set of possible values. So you have to describe the set of possible values. So you have to write all the possible values for these random variables. So in part A, we have random variable X, which is the number of X in a randomly chosen standard egg cartoon, and state whether this variable is discrete or continuous. So the number of unbroken eggs. So the number of eggs are whole number, right? So that's mean X can be 0. That's mean 0 unbroken eggs, 1 unbroken eggs, 2, 3, dot, 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 right? So this is discrete because X can take only discrete values. So this is discrete random variable. Part B will be the number of students. So the number of students also discrete, right? Because it's also integer, it's also a whole number. It cannot be a fraction, the number of students. On a class list for a particular course who are absent on the first day. So that's mean it can take 0. That's mean all students are present. 1 student is absent. 2 students are absent. 3 students, and up to the total number of students. So since we do not know the total number of students, so we do not know the end value. So that's why you have to just write dot dot. That's mean it will continue. So this is the number of students. So this is also discrete random variables. So this is also discrete random variables. So how about part C? The number of times a duffer has to swing at a golf ball before hitting it. So this is also number of times. So how many times? So it can also take 0. That means 0 times, 1 times, 2 times, 3 times, dot dot. So this is also discrete random variable. So part D is the length of a randomly selected rattlesnake. Okay, so the length of a randomly selected rattlesnake. The length is always positive, right? So the possible values for X will be positive. And this is continuous because the length can take fractional values. So it's not always integer. So it can take fractional values. So part D, the random variable is the length of a rattlesnakes. So this is also X. So the possible values will be actually greater than 0. So X can be any positive real numbers. So it could be 0.1, 0.2, 0.3, 0.5, 0.6, 1, 2, 1.2, 1.3. So it can take all the whole number integers or positive integers or fractional numbers. So that's why this is continuous. This is continuous random variable. And part E is Okay. So the sales tax percentage for a randomly selected Amazon.com purchase. So sales tax, so tax could be also 0, 0.5, 0.2, 0.3, 1.5, 1, 1.3, 10.5. So it can also take fractional numbers. So this is also continuous, and it could be, since this is the sales tax, so it could be 0 or any positive number. So this is actually greater than equal 0. The possible values will be greater than equal 0. Or you can just write 0 and all positive real numbers. And this is also continuous. This is also continuous. How about if the pH of a randomly chosen soil sample? So the pH also can take fractional values. So this is also continuous. The tension at which randomly selected tennis racket has been strung. The tension in PSI, it can also take fractional value. So this is also continuous. So they are so last four, they are continuous random variable, and first three are discrete. So this is discrete and they are continuous. Okay, so number 10, the number of pumps in a use at both 6 pump station. So a pump station has 6 pumps, and there is another pump station which has 4 pumps. Now give the possible values for each of the following random variables. So the part A, T is the random variable that the total number of pumps in use. So total number of pumps. So we have 6 pumps here, we have 4. So the maximum could be 10. So T can take the total number of pumps in use. So if 0 pumps in use at this station and 0 pump in use at this station, then the total will be 0 plus 0. So it can take 0. If 1 in use here and 0 is here, then it will be 1. So it can take 0, 1, 2, and if all of them are in use, then total will be 10. So maximum is 10. So T can take values from 0 to 10. So part B, X is the random variable that the difference between the numbers in use at stations 1 and 2. So you have to take the difference between the numbers in use at station 1 and station 2. So if 0 pump in use at this station, and so this is the first station and this is the second station. So if 0 pump in use here and 1 pump is here, then it will be, if you take the difference, then it will be 1. And similarly, if maximum here, the maximum can be 6, the minimum can be 0. So the difference could be, the maximum difference could be 6 or negative. So the maximum difference could be 6, right? So the maximum number is 6. Since we are taking the difference of at stations 1 and 2, so we are taking difference from 1 to 2. So the minimum difference will be then if it has 0 and it has 4. So if you take the difference, then it will be 0 minus 4. So it will be then negative 4. So that means it can also take negative 4. So negative 4, negative 3, negative 2, negative 1, 0, 1, and up to 6. Do you have any question? Okay, so part C is the random variable is U and the maximum number of pumps in use at either station. The maximum number of pumps. So U is the maximum number of pumps. So if 0 pump in use in station 1 and 0 pump in use in station 2, then the maximum is 0. So if 1 pump in use in station 1 and 0 pump in station 2, then the maximum is 1. So For U, the minimum value could be 0. So it cannot be less than 0. And the maximum value could be 6 because station 1 has 6 pumps. If all of them are in use, then the maximum number will be 6. So it can have up to 6, 0, 1, 2, 6. Is it clear, or do you have any question? Any question? Okay, so the last one is the number of stations having exactly 2 pumps in use. So you have to write the number of stations. So we have here actually 2 stations. Station 1, who has 6 pumps, and station 2, who has 4 pumps. So we have to write the number of stations having exactly 2 pumps in use. So station 1 and station 2. So it can have 0 pump in use, 0 to 6, right? So the number of stations having exactly 2 pumps in use. Okay, so exactly 2 pumps. So both stations cannot have exactly 2 pumps in use. So that's mean the number of stations that exactly 2 pumps in use could be 0. Because if station 1 has 0 pump in use and station 2 has also 0 pump in use, then no station has exactly 2 pumps in use, right? And one station can have exactly 2 pumps in use, and both station can have exactly 2 pumps in use, right? Because the maximum for station 1 is 6 and maximum for station 2 is also 4. So both station can have exactly 2 pump in use, right? One station can have exactly 2 pumps in use, and 0 station, that's mean no station can have exactly 2 pumps in use, right? So these are the possibilities. So the possible numbers could be 0, 1, 2. Is it clear? Okay, so okay, thank you. So from section 3.2 we have this question is really very nice question. So airlines sometimes overbook flights. Suppose that for a plane with 50 seats and 55 passengers have tickets. So the plane has 50 seats, but they sold 55 tickets. Define the random variable y as the number of ticketed passengers who actually show up for the flight. So y is the random variable, which is the number of ticketed passengers who actually show up on that day. The probability mass function of y appears in the accompanying table. So we are given the probability mass function. So the possible values that the number of passengers will show up here, we are given 45 to 55, 45, 46, 47, 48, and we have also 55. So because the total number of tickets sold is 55, so all the ticketed passengers might show up, then it will be problem. Okay, so part A, what is the probability that the flight will accommodate all the ticketed passengers who show up? So part A, we have, if y is the random variable, so when the flight can accommodate all the ticketed passengers, if the number of ticketed passengers who show up is less than equal 50, right? Because the maximum seat is 50. So they can accommodate maximum 50 passengers. So they cannot accommodate more than 50 passengers. So that's mean if y, the number of passengers who show up is less than equal 50, right? If 45 people show up, they can accommodate all of them. If 46 people show up on that day, they can accommodate all of them because they have 50 seats. If 47 people show up, they can accommodate all of them. If 49 passengers show up, they can accommodate all of them. If 50 passengers show up, they can accommodate all of them. But if 51 passengers show up, they cannot accommodate one person, right? They can accommodate maximum 50. So that's why we are looking for the probability that y is less than equal 50. So that's mean you have to add this up to this. You have to add the probability up to this. The probability is 0.05 plus 0.10 plus 0.12 plus 0.14 plus 0.25 plus 0.17. So this is the probability. So you have to add them together. So part B is so what is the probability that not all ticketed passengers who show up can be accommodated? So if the number of passengers who show up is more than 50, then the flight cannot accommodate all of them. So that's mean we have to find the probability y is greater than equal 51 or greater than 50, or you can just write probability y is greater than 50. If y is greater than 50, they cannot accommodate all the passengers who show up. So one way is you can add all the probabilities corresponding to 51 to 55, or you already have this probability, so you can use the complement. So you can just write 1 minus probability of y less than equal 50. So you can use the probability from part A, or you can also add all the probabilities from 51 to 55. Whichever is convenient to you, you can do that. Okay, so part C is if you are, this is really interesting question. If you are the first passenger on the standby list, so which means you will be the first one to get on the plane. So if you are the first person on the standby list, that means you will be the first one to get on the plane if there are any seats available after all ticketed passengers have been accommodated. So if you are in a standby list, then you will be the first one that you will be the first one to get on the plane after all the ticketed passengers have been accommodated. That means you didn't buy the ticket, and if the number of passengers who bought ticket and show up on that day is less than 50, then you will be accommodated, right? Then you can get on the plane. If there are 50 passengers, ticketed passengers, then there is no chance that you will get on the plane. So now the question is, what is the probability that you will be able to take the flight? So you are the first one on the standby list. So you will take the flight only when the ticketed passengers is less than 50, right? Because there are total 50 seats. So if there are 50 ticketed passengers there, then there is no chance that you will get on the flight. But if there are 49 passengers, since you are the first one, so you have chance that you will get on the flight. So that's mean we have to find the probability where y is less than equal 49. So that's mean we are looking for the probability y is less than equal 49, or y is less than 50. So you have to find this probability. And the second one is, second part of this question is, what is the probability if you are the third person? So if you are the third person on the standby list, so that's mean you will get on the flight as a third person if all the ticketed passengers do not show up. So that's mean if 49 passengers show up, then only one person can get in the flight. So that's mean you do not have any chance. If there are 48 ticketed passengers, then 2 person can get on the flight, but you are the third person. So for you will get on the flight only when the number of passengers who showed up is either 47 or less than 47, right? So that's mean we are looking for the probability where y is, so for this part, we are looking for the probability where y is less than equal 47. Okay, so now I am asking you some follow-up question for this one. So you have to answer these questions. Okay, so if you are the sixth person on the standby list, then what is the probability that you will get on the flight if you are the sixth person? Anyone? Okay, so if you are the sixth person on the standby list, is there any chance that you will get on the flight? Okay, the first person, if mhm, okay. Okay, I didn't ask you to type present yet. Okay, so the answer is no. Yes, the answer is no, right? Because the first person, if number of ticketed passengers show up is 49, then the first person will get on the flight. The second person, the third person, the fourth, the fifth person can get on the flight, but the sixth person doesn't have any chance. So that's mean the probability is zero. And similarly, if you are the seventh person, the probability is zero. If you are the 8%, the probability is zero that you will get on the flight. Okay. So now I'll give you time for the attendance. So you'll have 3 minutes for the attendance. And after that, um, if you want, you can leave the class, or if you want, you can continue the class. How many questions we have? 1, 2, 3, 4, 5. Yeah, we might need 30 more minutes to finish the review problems. Yeah. Okay, so this is from section number 13. Okay, so I'll try to go over any of these two problems, 23 and 24. They're similar type of problems, but we didn't discuss this type of problem in the class. So I think I should go over this one. Yeah, we discussed the cumulative frequency, but we didn't solve this type of problem in the class. Okay, so let's go over this problem, number 23. So here we are given the cumulative frequency, and f of x is 0 when x is less than 0, and f of x is, so what is f of x? F of x is probability of x less than equal x. So here x is discrete random variable and x represents the number of machines. So the possible values for x will be 0, 1, 2, sorry, 0, 1, 2, 3, 4, and the maximum is 6. So 5, 6. So these are the possible values for x, 0, 1, 2, 3, 4, 5, 6. So the cumulative probability means we are adding the probability. So x less than 0, that means the possible values which are less than 0. We do not have any possible value here which is less than 0. So the probability is 0. When x is between 0 to 1, so that's mean probability of x less than x is between 0 to 1. So if we take any number between 0 to 1, for example 0.5, so how many possible values we have for x which is less than 0.5. How many possible values do we have which is less than 0.5? Anyone? Okay, so when x is less than 0.5, that's when we have just one possible value. 0 is less than 0.5, right? So we have just one possible values which is less than 0.5. So that's mean this is actually probability of x is equal 0. So this is 0.06 because we are given this is 0.06. And the next one is if x is between, if f of x is 0.19 when x is between 1 to 2. So that's mean if x is between any number between 1 to 2, for example 1.5, so then the possible values are x equals to 0, plus probability of x equals to 1. We have two possible values. So we know the probability, and this is equal, this is the, and in this case the CDF is 0.19. So that means sum of this two probability is, sum of this two probability is 0.19. So this is equal 0.19. So we know the probability for x equals to 0, which is 0.06. So to find the probability of x equals to 1, you have to subtract 0.06 from 0.019, right? So that's mean probability of x is equal 1 will be 0.19 minus 0.06. So this is the probability when x is equal 1. So in part A, we have to find the probability of x is equal to. So how can we find this probability? We have to find probability x is equal to. So probability of x is equal to. So this is actually probability of, so we can say probability of x less than equal to minus probability of x less than equal 1, right? Because if you write probability of x less than equal to, then it will be, the possible values will be 0, 1, 2. And for x less than equal to, and for x less than equal 1, the possible values will be 0 and 1. So if you subtract the probability for this one from this probability, then you will get the probability for x equals to exactly 2, right? So this means f of 2 minus this is f of 1. So what is f of 2? F of 2 is, that's mean the value of f of x when x is 2. So where x is 2, here x is less than 2, so x is equal to will be here. So that's mean f of 2 is 0.39. So this probability will be then 0.39. So this will be then 0.39, and f of 1 is 0.19. So it will be then 0.20. Okay. So similarly, if we want to find the probability x is equal 3, so how can we calculate this probability? Anyone? How can we calculate this probability? You can do this similarly. So this is actually probability of point x less than equal 3 minus probability x less than equal 2, right? So that's mean this is f of 3 minus f of 2. So what is f of 3? So f of 3 means the value of f of x when x is equal 3. So here x is greater than equal 3 and less than 4. So that's mean x is 3 is here. So this is 0.67. And f of 2 is here, which is 0.39. So that's mean this probability will be 0.67 minus 0.39. So this will be 0.67 minus 0.39. And similarly, we can calculate f of 4, we can calculate f of 5, we can calculate f of 6. Okay. So now the question is, the part B is probability of x greater than 3. So we have to calculate probability of x greater than 3. And for CDF, we already know that CDF is always less than equal. CDF will give you the probability always less than equal. So in that case, we can use the complement. We can use 1 minus probability of, since this is greater than equal 3, so 1 minus probability of x less than equal 3. So that's mean 1 minus f of 3. So that's mean 1 minus, and f of 3 is 0.67. So 1 minus 0.67. So this is the probability. And similarly, we can find the probability for part C. And part C is probability between 2 and 5. So part C is probability where x is between 2 and 5 and inclusive. So this is actually f of 5. So that's mean probability x less than equal 5. And we have to find the probability from 2 to 5. So 2 is also included. So that's mean you have to subtract up to 1, not up to 2. So f of 5 means the probability up to 5 minus the probability up to 1. Because f of 5 will give you the probability from 0 to 5. But we have to find the probability from 2 to 5. So you have to subtract 0 to 1. So that's why we subtracted f1. So f of 5 is from here. F of 5 is here, which is 0.97, and f of 1 is 0.19. So 0.97 minus 0.19. So this is 0.97 minus 0.19. Similarly, you can find the probability for part D. So part D is probability between 2 to 5. So probability between 2 to 5. So that's mean 2 to 5 means 2 and 5 are not included here. So that's mean we have to find from probability 3 to 4. So 3 to 4 means f of 4 will give you the probability from 0 to 4. You have to subtract 0 to 2, right? Because we want the probability from 3 to 4. So f of 4 will give you the probability from 0, 1, 2, 3, 4. And f of 2 will give you the probability from 0, 1, 2. But we need from, this is actually from 3 to 4. So you have to subtract this one. So that's why we are subtracting f of 2 from f of 4. And it will give you the probability from x2 to 5, and 2 and 5 are not included. And similarly, you can find the other probabilities. So if you want to find the probability from, suppose 1, x less than equal 6. So that's mean f of 6 minus f of 0. So f of 6 will give you the probability from 0 to 6, but we need the probability from 1 to 6. So that's why we subtracted probability from for 0. And similarly, if you want to find, for example, if we want to find the probability x less than equal 7, then it will be actually f of 7. So for any number which is greater than 6, the probability is equal 1. It is given in the CDF function. So in the CDF function, it is given if x is greater than equal 6, if it is equal 6, the probability is 1. If it is x is greater than any number greater than 6, then the probability will be 1. So for f of 7 is 1, f of 8 is also 1, f of 8.7 or any number, if you consider any number which is greater than 6, the cumulative probability will be 1. Do you have any question? Okay, so if you do not have any question, then I'm not going over all the problems. So if you want me to go over any specific problem, then I can go over that problem. Is there any specific problem you want me to go over? Okay, okay, thank you. Or if you have any questions, so your exam will be one Thursday. So if you have any question, you can just email me. And tomorrow you will have office hour. So if you have any question, you can just join the Zoom meeting for the office hour and you can ask me, okay?
Professor,
Yes.
I had a question real quick. It was like the second problem you did. Trying to find it real quick.
Yeah, sure. The second problem.
From section 1.3 D.
Yeah, 1.3. Yes, part D.
Yes.
Okay, sure.
I solved it. I used a slightly different method, and I you're doing it your way too. And the answers are essentially the same. They're just a little bit different.
Okay.
And would WebAssign count that wrong, or would it probably take it?
The WebAssign, I think if the error is plus minus 5%, I think
Yeah.
it will take, yeah.
Okay, because it was just like
Mhm.
one place difference. So
Okay, I think it will be fine, yeah.
okay, thank you.
You're welcome. Any other question? Yeah, okay, so if you do not have any other question, then I'll leave the class now and best of luck.